We need to find out the value of the given trigonometric expression. So let us begin. First, what we'll do, we'll try to simplify each of the trigonometric ratio. So let's begin with our cosecant function. So we're cosecant of 90 degree plus theta. Now cosecant of 90 degree plus theta, this can be also expressed as cosecant of 1 multiplied to 90 degree plus theta. The reason why we wrote in this fashion, because we have an odd multiple of 90 degree, because 1 is an odd number. So whenever we have an odd multiple of 90 degree, then cosecant function must transform, and this will transform to secant function. So we're going to get secant function, and the new angle is going to be theta. Also, we have to check for the sign of the final value. So we have 1 times 90 degree, so that means we are in the first quadrant. So we start from the first quadrant and go into anti-clockwise fashion. So 1 plus 90 degree means we are in the first quadrant, but we are also adding an angle theta to it. So theta is an angle which lies between 0 and 90 degrees. So that's going to take us to the second quadrant. Now in the second quadrant, the sine and the cosecant are positive. So since we started out with the cosecant function, so its final value is going to be positive in nature. So that means cosecant of 90 degree plus theta is positive secant theta. Now let's try to find out the value of cotangent of 450 degrees plus theta. Now what we'll do, we'll try to rewrite 450 degree as a multiple of 90 degree. So we have cosecant of 5 times 90 degrees, so that's 450 degree plus theta. So this is cotangent function, so we have cotangent here. Now since it's an odd multiple of 90 degrees, the cotangent function must transform. So it will transform to give us tangent function, and the new angle will be theta. Now we need to check in which quadrant it lies. So we start from the first quadrant. So 1 times 90 degree, 2 times 90, 3 times 90, 4 times 90, and then 5 times 90. So that brings us to the first quadrant. But we are also adding theta to it, which is going to take us to the second quadrant. Since in the second quadrant sine and cosecant are positive, everything else is negative. So we are working with a cotangent function, so its value is going to be negative in the second quadrant. Then we come to cosecant 90 degree minus theta. So we have cosecant of 90 degree minus theta, which will be equals to cosecant of 1 multiplied to 90 degree minus theta. So since we have an odd multiple of 90 degree, so cosecant must change to secant. So we're going to have secant theta. Now 1 times 90 means we are in the first quadrant. This time we're subtracting theta from it. Now theta being an angle between 0 and 90 degrees, so we're still going to lie in the first quadrant. So in the first quadrant, all trig functions are positive. So we're going to get positive secant theta. Now going to tangent of 180 degree minus theta. So we have tangent 180 degree minus theta. So this will be equals to tangent of 2 times 2 times 90 degrees, so that's 180 minus theta. Now we have an even multiple of 90 degree. So whenever we have an even multiple of 90 degree, then the tangent function is not going to transform. It's going to remain as the tangent function, but the new angle is going to be theta. So 2 times 90 means we are in the second quadrant, and subtracting theta, we are still going to lie in the second quadrant because theta is an acute angle. So we have the sine and cosecant positive in the second quadrant. Since we are working with the tangent function, so this value is going to be negative tangent theta. Then coming to tangent of 180 degree plus theta. So we have tangent of 180 degree plus theta. So this will be equals to tangent of 2 times 90 plus theta. So we have an even multiple of 90 degrees. So this is going to remain as tangent function. We have tangent of theta. 2 times 90 means we are in the second quadrant, but we are adding theta to it, taking us to the third quadrant. Third quadrant tangent and cotangent are positive, so we're going to get positive tangent theta. Then we have secant of 180 degree minus theta. So this should give us secant theta. And we are in the second quadrant, so this is going to be negative secant theta. You need to check it out. So I'm leaving it as an exercise for you to try. Then we have tangent of 360 degree plus theta. So this is going to be equals to positive tangent theta. So 360 plus theta means we are in the first quadrant. And finally, we have secant of negative theta. Now secant is an even function. So secant of negative theta is going to be secant theta. Now that we have obtained the simplified value of each of the trigonometric ratios, so we're going to replace all of these trigonometric ratios with their simplified value. So let's do that. So here we have cosecant of 90 degree plus theta. So we have already obtained that cosecant of 90 degree plus theta, that's positive secant theta. So let's replace it here. So we have positive secant theta. Then we have cotangent of 450 degree plus theta, so that's negative tangent theta. Whole divided by, we have cosecant of 90 degree minus theta, so we have obtained that secant theta. So we have secant theta plus tangent of 180 degree minus theta. This came out as negative tangent theta. Fine. Then going to the next fraction, we have tangent of 180 degree plus theta, so that's positive tangent theta. And we have secant of 180 degree minus theta, so that's negative secant theta. Then in the denominator, we have tangent of 360 degree plus theta, so that's positive tangent theta. And we have secant of negative theta, so that's negative secant theta. So this is going to give us, sorry, my mistake. So secant is an even function, so this is going to be positive secant theta, my bad. So we have negative of secant of negative theta, so that's going to be negative secant theta. So secant theta minus tan theta gets factored out from the numerator and the denominator, leaving us with 1. Similarly, in the second fraction or the second term, tan theta minus secant theta also factors out to leave us with 1. And this is going to give us a value equals to 2. So that means the value of this trigonometric expression is equals to